So just quickly review what we talked about. Are there echo? No. So I believe you understand how I calculated the total transfer time in a given scenario. If I twitch a little, then you may be able to compute the complete time to deliver all the packages, right? Then do you want to review this? No?
Yes.
May I continue? Because some of you asked about it, but that it was detailed. Hamin, please.
Can you just explain it one more time?
Okay, which one?
The one on the screen.
This one?
Yes, please.
Okay. So I think this is the first one. So my job is deliver 1.5 megabyte file. Okay, therefore it is 1.5 megabyte. And assuming your RTT is 80 millisecond and packet size is 1 kilobyte. Okay, initial handshake we need to do the 2 times of RTT. Okay, so bandwidth is 10 megabps. And data packets are sent continuously. Sent continuously meaning I can just keep sending it. Okay, without feedback. Okay, so RTT 80 millisecond meaning propagation delay, propagation time is 40 millisecond. Transmission time is, I have packet size is 1 kilobyte. Therefore, I have to make 1 kilobyte in a given network environment, which 10 megabps. Therefore, transmission time is 0.81 millisecond. And number of packets I have to consider is 1.5 megabyte. And I can send 1 kilobyte. Therefore, it is 1,536 packets. And what I have to do is first, I have to do initial 2 handshake, meaning can I send it? Yes, you can. Okay, here we go. Okay, I got you. Okay, then I can continuously sending my packages, Let me set my network environment a little differently. Okay, so what I have to do, I have to send 1,536 times of transmission. I have to repeat it. Then in the end, I have to wait for this event to end. Okay, therefore I have to consider propagation time. Therefore total is 1.47. Clear?
Yes.
So I can hear you well, but there are loud static noise coming from your mic. How about now? Is the noise gone?
The noise gets quieter when you talk, so I guess I think it's fine. Yeah.
Okay, how about now? Much better or same?
I think it's much better. Yeah.
Much better. Okay. I just turned it off my air conditioning.
Oh, okay. Then you can turn it on like if it's hot.
Don't worry. So I just opened the window. So next question was, so my voice and presentation has some syncing issue. Don't know why. And Yeun keeps sending me invitation, and she is not able to join in. Okay. I think it is her computer problem. Okay. So, okay, the next question was, after sending each packet, you must wait 1 RTT, then 2 RTT initially, you have to repeat it, and 1 RTT at the end, you don't need to wait for half RTT, so only 40 milliseconds. The propagation time is only considered. Okay, so let me. So is it okay for the delaying issue that I'm touching in my voice and the screen has some delay issues? If you guys find, I can go ahead. So example, the next one is 20 packets per age. I think we covered enough for this case. And we also talked about the exponentially increasing. Then it ends up with the 1 second. And today, I want to talk about what is a latency and what is a bandwidth, and which one should we consider more, and how does it impact for your file delivery. Okay, so first, latency. What's the latency? How long does it take from end to end, point A to point B, right? Bandwidth is how much can you deliver in a given time? So how fast is it? Maybe very related to of these two factors. Okay, so let's say you have to deliver 1 byte file, and let's say you have to deliver 1 gigabyte file. Okay, so I have 1 byte file, something like my voice. Okay, and I have 1 giga file, like something movie kind of thing. And which network should I choose? Network 1 has 1 millisecond latency, and bandwidth is 1 megabps. The network B has 100 millisecond, but the network is 100 megabps. Okay, if I have to send this on the left, how long does it take? So since I have to deliver, I have a 1 millisecond latency, 1 millisecond edit, plus I have 8 bits in a given 1 to 6 bits per second. Therefore, bits and bits, it becomes a second. Then it is 8 e to minus 6 seconds, which is 8 microseconds. Okay, then in the end, the time's adding up to 1.008 millisecond. If I'm using network 2, I have to count latency, and I have 8 bits divided by 100 e to 6 bits per second. Therefore, bits and bits, it will be second. Then 0.08 e to minus 6. Therefore, 0.08 microsecond. Then it ends up with the 100 millisecond plus 100 0.00008 millisecond. Okay, so roughly 100 milliseconds. So which one is better choice? In this case, in a small file, time sensitive, I have to use smaller bandwidth, but smaller latency. Okay, and if I have a 1 giga file, I have 1 millisecond I have to add, and 1 giga. So 8 e to 9 divided by, in a given network, is 1 m bits per second. Therefore, it is a second. You are 8 e to 3 second, which is almost 2.13 hour. Then it will be 2.13 hour and 1 millisecond. And the network B takes latency, your network, e to 9 divided by given network, 202 e to 6 bits per second, bits and gone in a second. Then it is 6 is a 3. And therefore, it is 0.08 millisecond. Plus 100 millisecond, right? 0.08 k second, right? So 80 second plus 100 millisecond is 80.1 second. Okay, so it took longer. So B took longer. So if I'm sending a bigger file, I have to choose network B. Okay, if I'm sending a smaller file, I have to choose a network A. Why? In this case, I'm sensitive to latency. In this case, I'm sensitive to the bandwidth. Because I have a bigger package, I have to care about how much can I carry in a given time, not the latency. Okay, so both of them are important, but based on your application, you have to choose properly. So this is a good example of the 3G, 4G, maybe 5G, the LTE kind of thing. And this is a good example of the Wi-Fi. Wi-Fi has a big latency, but big bandwidth. But LTE has a small latency, but a smaller bandwidth. Okay. So anyone knows Yeun's contact? I think she's struggling on joining the lab. Oh, she's now on. So, so we just covered about what the latency and the bandwidth impacts your file delivery. Now, bandwidth and delay product. What does that matter? So if you think about the pipeline, let's say you are delivering oil, something like LNG, LPG, or your gas, then it travels the pipeline over the country. So what does it matter? Is it how small it is or how wide it is? Okay, and how fast it travels. How fast it travels is a delay, and how wide is your pipe is bandwidth. So both of them are important. So we call bandwidth and delay product. So example, if I have 100 megabps bandwidth and latency of 10 milliseconds, then it is 1 megabit, meaning the amount of data sent before the first byte arrives. So how much the data can stay in your pipe. Okay, so usually use RTT, round trip time, as a delay, and amount of data before a reply from receiving arrives to the sender. So if you have a bigger chunk, then it is more efficient and it can deliver a bigger file. So for example, this is the example of the high-speed network. So dial-up, you may not know about the dial-up. A long time ago, when I was a middle school student, high school student, I used the dial-up network. So for to join the internet world. So I'm using my mother's phone, wired phone, then I was able to access it. And the bandwidth is very shallow, 56 kilobps, and distance 10 kilometer roughly, because it is wired and it is using copper wire, and round trip time is 87 microsecond, and delay and bandwidth product is 5 bits, very small. And Wi-Fi, what you are using, is 54 megabps, and distance only up to 50 meter, and RTT is 0.33 microsecond, and delay bandwidth product is 18 bits. And satellite link, if you are emergency or if you're doing something important, you may use the satellite. And bandwidth is 45 megabps, and distance is 35,000 kilometer, and RTT is 230 millisecond, and delay bandwidth product is 10 megabits, which is delay. What is the meaning of the delay and bandwidth? Delay bandwidth product. It is amount of data in your pipe. And cross-country fiber is very fast, 10 Gbps up to your environment, but it could be jumped to 40 G these days. And distance up to 4,000 kilometer. And RTT is a 40 millisecond, and delay bandwidth product is 400 megabits. Okay, so if you have infinite bandwidth, then propagation delay dominates your network. If you have infinite, if your pipe is wide enough, infinitely wide, then propagation delay dominates, of course. Okay, and how can you calculate the throughput? Throughput is file size divided by transfer time, and this transfer time is RTT plus transfer size divided by bandwidth. Okay, so 1 mega file across the 1G line with the 100 millisecond, the throughput is 74. Let's calculate this. Okay, can you see my screen, the Excel file?
Yes.
Yes.
Okay, thank you. So sync issue, yes, we have sync issue. I'm using my iPad, and I'm using my notebook as a recorder. So let's try to do, let's focus on my notebook, then we can naturally solve the syncing issue. So in a given problem, is throughput is T size, transfer size is T time, and I have RTT and bandwidth. So in a given network, transfer size, where is the size? Size is 1 mega, and 1 G bandwidth. So what is 1 megabyte? So I have to multiply by 8. And RTT is 100 millisecond. And what is the throughput? Let's calculate this. So to do that, I have to know transfer time. Transfer time is RTT plus transfer size divided by bandwidth. Okay, now I have transfer time. Throughput is file size divided by this guy. Okay, so what is this value? It is 74. It is 74 E6, right? Which is 74 E6 is 74 mega, and throughput is BPS because we calculated in bits per second. Okay. So it says 74, in the slide it says 74 BPS. Okay. Okay, how about now? Is it better for your syncing issue? Sync issue? Then we just calculate the 74 Mbps. It's still there. You still have 74. So we just calculate the 74. Okay, let me try this. Try. Is it better for, is it the sync issue still there? No? Still here, you mean? How about, what if I turn off the video? Stop video. Is the syncing issue still here? Try. It's still here, but a little better. Better. Yeah, about less than 1 second. Previously it was like 2 seconds. Maybe it don't impact. How about this? Hello. Better. Okay. Okay. I think it is much better before. So let's compute one more. Let's compute one more example. Thank you, Yang. So computing application with the bandwidth. So FTP utilize a entire bandwidth which is available, but BOD may specify upper limit. Only what is needed. Why is it? Your purpose of FTP is to deliver the whole file in the fastest way. And the video on demand only require a small section of, a small portion of the bandwidth, right? Because you only utilize it. And therefore some other application may use your bandwidth, may share the bandwidth. Okay, so let's solve this problem. Example, okay, you have 352 by 240 pixels, like your screen, and your screen using a 24 bits color, and frame speed is 30 FPS. 30 FPS means 30 frames per second. I'm sure you understand these terms, right? Pixels, what is a pixel? In your screen, it is all dotted. So how many pixels are there in a vertically and horizontally? 352 by 240 means you have 352 pixels and 240 pixels. And the total pixels are the multiply is the total pixels you have. Okay. These days you may have full HD, which is 1920 by 1080p, and 4K is 4K by almost 2K, and 24 bits mean the color that you are using is a 24 bits word. The very simple word is 1 bits word. 1 bits word is I'm using a black and white. So 8 bits word meaning gray word, 1 to 7. So it is 8 bits gray word. So 24 bits is the usual choice of the today's technology. It comes with the 3-layer RGB. Each layer, each channel has 8 bits, 0 to 7, 0 to 7, 0 to 7. Then make a combination of it, then you can see the true color of it. And 30 frames per second. The screen, you maybe have a 30 FPS, but if you are sensitive or if you're a gamer, you may have 144 hertz screen, which flicking the screen 144 times per second. Okay, for the video, for the YouTube video, unless you are using special device, it is all 30 FPS. Okay, there is a 60 FPS or 120 FPS, but the usual case is 30 FPS. So how much bandwidth do we need in a given environment? Okay, so this is how you calculate it. So each frame is width multiply height, and I'm using 24 color. Then I'm making up to byte. Then when I want to make a byte to bit, I'm multiplying 8. When I want to make a bit to the byte, I'm dividing it. Okay. Then each frame is 247 kilobyte, and total bandwidth required is, I have this information, and per second, I have 30 of those. So 60 megabps. That's a basic calculation. But in real world, it is not true. Because let's say you are using YouTube. Okay, YouTube, you are watching full HD, which is, okay.
드립니다. 지구 후 태풍 마이삭이 우리나라를 향하고 있어 태풍 피해 우려가 있습니다.
Sorry.
캠퍼스 거주자분들께서는 다음과 같은 사항을 주의하시어 피해가 없으시기를 바랍니다. 각 사무실 창문 및 복도 창문은 태풍에 날아갈 우려가 있으니 모두 시건하여 주시기 바랍니다. 바람에 날아갈 물건이 주변에 있다면 미리 제거하거나 방제실 및 캠퍼스 근무자에게 신고하여 주시기 바랍니다. 마지막으로 인명사고에 우려가 있사오니 외부 활동을 자제하여 주시기 바랍니다.
May I have your attention, please? This is Incheon Global Campus Emergency Office. As the Minat Typhoon Maysak is heading towards Korea, we need your cooperation to prevent damaging the campus. Please close all windows in the building and put away things that may blow away in the wind. If you find any issues that should be taken care of before the arrival of typhoon, please report to IGC Emergency Office. In addition, please minimize outdoor activities for your safety. Thank you.
인천 글로벌 캠퍼스 통합 방제실에서 안내 말씀드립니다. 지구 후 태풍 마이삭이 우리나라를 향하고 있어 태풍 피해 우려가 있습니다. 캠퍼스 거주자분들께서는 다음과 같은 사항을 주의하시어 피해가 없으시기를 바랍니다. 각 사무실 창문 및 복도 창문은 태풍에 날아갈 우려가 있으니 모두 시건하여 주시기 바랍니다. 바람에 날아갈 물건이 주변에 있다면 미리 제거하거나 방제실 및 캠퍼스 근무자에게 신고하여 주시기 바랍니다. 마지막으로 인명사고에 우려가 있사오니 외부 활동을 자제하여 주시기 바랍니다.
May I have your attention, please? This is Incheon Global Campus Emergency Office. As the Minat Typhoon Maysak is heading towards Korea, we need your cooperation to prevent damaging the campus. Please close all windows in the building and put away things that may blow away in the wind. If you find any issues that should be taken care of before the arrival of typhoon, please report to IGC Emergency Office. In addition, please minimize outdoor activities for your safety. Thank you.
Okay, so.
Professor?
Yep.
I still don't understand why, when we calculated each frame, why at the end we divided everything by 8.
Okay, so I'm gonna explain to you. So why do we multiply 8 or divide by 8? Okay. Do you see my screen, the black screen? So let's say I'm calculating bits or let's say I'm calculating the bytes. Okay, so network guys start to talking about, okay, I'm having Mbps, megabits per second, because I want to emphasize it. Let's say I achieve 1G network. In a network world, means 1G BPS, bits per second. Okay, the computer science in the data size and file size, and maybe database, and all the rest of it. Then talking about byte information. So my data is 1 gigabyte. That's what these people are talking about. So whenever we calculate it, we have to synchronize it properly. But in the view of the computer database guy, 1 Gbps is actually about 168 megabytes per second. Okay, but the network guys want to say, okay, I just achieved 1 Gbps. There is some sync issue, and when we talk about bytes or bits, we have to specify, we have to clarify. Okay, that is why we have to multiply 8 when we want to talk about bits word from bytes word, and divide by 8 if I'm talking about bits word to the bytes word. Okay, that is why.
I see. Okay, now I understood.
Okay, so thank you. So this is what we need. So it's more delays. Is it better? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We can use this. How about this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ah. Okay, I don't think we can use this. It's about 20 seconds of delay. Okay. I'm sharing it. Okay. 1, 2, 3, 4, 5, 6. About 6 seconds delay. Seriously. Let me try again. 1, 2, 3, 4, 5, 6. About 6 seconds delay. Why do we have so much? Let me try again. It says your network low has a low bandwidth. Okay. Let me rejoining the lab. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. My network has about 20 seconds delay. Let me try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 seconds delay. Oh, we can't use this. Let me remake the room Zoom link. Let me make a new room for this. Okay, I'm gonna close this Zoom link and I'm gonna set up the new Zoom link. Please join to the new Zoom link.